AB negative is very rare. And so, because it's difficult to be AB negative. And we'll explain what that means. Okay. But yeah, just a review. We're talking about biological fluids and stains. We went over the terminology, and remember the plasma was the liquid portion of the blood. The serum is what's left over if you try to spin it, like after it's clotted or if you spin it down. We went over the antigen. Antigen elicits an immune response, and in particular, it's a part, and I've got a picture I'll re-show again. It's the part of the antigen that the antibody recognizes is called the epitope. Okay, the antibody is what your body has. It's a molecule, a protein, that your body has for its immune response that will recognize the foreign article. It's also when you hear about these autoimmune diseases, that's where your body makes antibodies against itself. So it literally will start to attack itself. So things like rheumatoid arthritis is an autoimmune disease. That's what I can think of off the top of my head. It's where it starts to attack its own joints. Okay, the anti-serum, we talked about that, and how that's the response for if you elicit the serum into, like say, a rabbit in order to get the anti-serum, which will have the antibodies from that in there. And then agglutination is the clumping. And so this was the picture that depicted the components of the blood. In particular, the relative sizes here are important. The white blood cells are huge compared to the red blood cells. And red blood cells are what carries oxygen and carbon dioxide, it carries the oxygen. And then if you're around carbon monoxide, like the carbon monoxide poisoning, that's what actually gets caught there as well. Okay, proteins and enzymes, and then we have the inorganic substances, things like magnesium and other metals, calcium, stuff like that. Yeah.
Why do they use this horse's blood, like horse blood and like snake venom to make the antivenom? Is there something in like horse's blood that is different?
No. So chances are, a lot of times whenever we go to make antibodies, to get the antibodies, we use it in animals because what they do is they literally will take the animal and they will inject the animal with whatever you're wanting to make the antibody against. That way the animal gets sick, creates its antibodies, and then you have to kill it. And so you don't want to do that with a human, if at all possible. Now, that being said, recently in the news, we've heard about the Ebola outbreak. In fact, just the Dallas just had a second person's come down with Ebola today. And then they talk about donor antibodies. That is where they've run out of the medication that they gave the first couple of people here in the States that got better. They've run out of that medication because it takes months and months to make it. Okay, so what they've done now is especially the male doctor, missionary doctor, by the way, who came down with Ebola by helping people in Liberia, and they flew him to Nebraska, and he's been healed since then. Thank God. What they're doing now is he is donating his own antibodies, his own blood. And so what they do is they try to get the antibodies out of his blood, and they're giving that to other people now. And so, because they hope that maybe his antibodies will help combat the Ebolas in these other victims. And so what they believe has happened to help heal him was that when he was in Liberia before he came over, a 14-year-old boy who had survived Ebola, donated his blood to this doctor. And now this doctor is donating his blood once again to the nurse. Pardon? Right. And so, it'd be HIV. And the life expectancy with HIV is much, much higher than it is with Ebola. And so Ebola right now has a mortality rate of 70%. And so it's not the easiest to catch, but once you have it, you've got a 70% chance of dying. Okay? And so both of the people in Dallas who contracted it were medical workers that were working on the guy from Liberia who came over and he died here. And so, they're doing an investigation. They believe that he lied on his, entrance or he was not fully honest on his entrance into the United States, and he was asymptomatic when he came over. Because it takes, usually on average, 8 to 10 days before you show symptoms, and that's when you're contagious, but it can take up to 21 days. So, it's been in the news that the nurse in Dallas who contracted it while working on this man, her dog, has been quarantined, and so the dog's gonna be quarantined for up to 21 days to make sure that the dog doesn't have Ebola. So, okay, but this turns out a little nicer on this platform rather than using PowerPoint. But this is, if you take a blood sample, and you spin it down really fast in a centrifuge, it goes round and round many times the centrifugal force of gravity. It'll separate out, and about 45% of it is, almost half, is red blood cells. Just over half is plasma, so the liquid portion, and then a very, very small portion of it would actually be white blood cells and platelets, proteins and things like that. Okay, and so you can kind of see it separate out here, where you get the red blood cells and the plasma. You won't be able to see the little fine line of the white blood cells because it's such a small percentage, unless you have something like leukemia, or you've been fighting off an infection. Then you'd have a higher percentage of white blood cells. Okay, because leukemia is the cancer of white blood cells. So, okay, and I mentioned the fact that if you're eating a really fatty meal and you try to donate blood, it actually comes out cloudy. Like you'll see the fats and the oils in your blood until it gets, either excreted out of your system or it gets stored in your body someplace. It's lovely. All right, and so we have this. Like I said, this is probably the most difficult, between this and just understanding DNA, those are the two most difficult parts of this chapter. But the whole idea of antigen versus antibody. The antigen is what it would be the foreign, if you have an immune response, it's what elicits the immune response. Okay? The antibodies are the proteins that are floating out in your blood that recognize the antigens, will bind it, clump together, and that way, hopefully, you can get rid of whatever that foreign invader is. And so that's why one way that they've tried to work against cancer is they have tried to create antibodies against the cancer cells, so that way your own body would try to fight the cancer. And they've had some success, but first of all, it's a really expensive treatment. But it's still in the early stages of using antibody therapy. So this is just depicting the red blood cell with the antibodies being expressed on the outside and the antigens. And I like this cartoon better because it's a little more simple to see. The antibody really does look Y-shaped. It's kind of look like a twisted Y when you look at it in 3 dimensions. But the very ends of the Y are the part that bind, and they bind very tight and very specific for that epitope that's being expressed on the antigen. And so this is, and as I was mentioning, this is why you get your vaccinations, because what they've done is they've taken the modified virus or disease or what have you, they've made it dead, chopped it up in little pieces, and they put it in your body whenever they give you the injection. The whole idea is you get an immune response. It's one of the reasons why sometimes when you first get your shot, a booster shot, you may get a little rash or a little swollen right at the shot, the point where they gave you the shot. Or they may even tell you that you may get a slight fever or something right after you get your booster shots or your immunization shots. The reason why is because your body is creating an immune response to that shot. But it's called attenuated. I use the word killed, but viruses technically aren't alive to begin with. But it's an attenuated virus that they put it out. So that's why your MMR, which is measles, mumps, rubella, that every child in the United States has to have, to go to school. That's a series of shots that you get when you're a kid in order to have an immune response against measles, mumps, and rubella, which are the German measles. Okay, and this was agglutination, just to show it really does clump, since each antibody has at least 2 arms or hands to grab on to 2 different foreign particles, then they all get clumped up together in order for the macrophage to come along and chew it up. Okay, so that way it hopefully doesn't elicit some other type of physical response. And then this is to show that some of these antibodies are not just one Y put together, but they're actually multiple Ys, and so they can even grab larger things and more things and hold on to them. Okay, the technical term for this is called phagocytosis. Phago means actually to chew or to eat, and cytosis is the engulfing of a cell. And so this is just to show the macrophage, which would be the white blood cell. It's huge, especially even compared to little bacteria like E. coli. And so we get this immune response. We have a whole bunch of antibodies that then grab on, and then the macrophage can come along, recognize its own antibodies, and say, okay, this shouldn't be here, so I'm going to eat it. And it slowly engulfs it like a big blob, and then has enzymes and stuff on the inside that does chew it all up. Spits little pieces of it back out in order to create more antibodies against it, against whatever that foreign invader was. Okay, so this is, I do believe, where we left off in the new stuff. So there's actually lots and lots of different blood types. The most common two that are used are called the ABO blood typing. That's whenever people say, I'm type A, B, B, or O. And then that plus or minus, which is the rhesus factor. It's named after the rhesus monkeys. And for whatever reason, they call the antibody for it D. Historically, I don't know why the D has not R or R. They call it the Rh factor for rhesus, but the antibody against it's called D. Okay, but for example, if you have type A blood, what that means is your blood cell actually has the A antigen on the outside. So then your body will make antibodies against type B. So it's called anti-B. So that way, if someone who has type B blood tried to donate blood to you, you would actually have an allergic response to it. Because your antibodies are against B, so they're anti-B. So you have the A antigen on the outside of your blood cell, but antibodies in your blood serum itself is actually going to be anti-B. If you have group B, type B blood, then that means that you have the B antigen on the outside of your blood cell, and in your bloodstream, the serum, you've got anti-A. If you have group AB, because what we're going to find out is you get one chromosome from your mother and one from your father. And so if you have an AB, that means one parent had type A, one parent had type B, and you get type AB. So if you have AB, then you've got both antigens on the outside of your blood cell, and you have no antibodies against either A or B, because otherwise your body would attack itself and you would die. Okay, and if you have type O, it means you have neither A nor B on the outside of your blood cell, and so you have antibodies against both floating in your bloodstream. And so that's the reason why if you're type O, you can only get blood from other type O people. If you got blood from type A or type B, you would have an immune response. But type O people can give blood to A, B, or AB because our blood cells have no antigens on the outside. Now, the plus or minus is a different type. So that's a different little picture. Let me just draw. So for example, if you are A positive, that means that you would have the little rhesus, I'm just going to put an RH there, hanging off of it too. And so you wouldn't have the antibody for it in your blood. If you are AB negative, that means you didn't have the rhesus factor on the outside, and so you would have the antibody against it in your bloodstream. And so that's why people say, I'm O positive or O negative. O negative, once again, would have nothing, neither the rhesus nor the A nor the B. And so we would have all three antibodies against it. Okay. And so this is just the same table, but without pictures. So some people prefer the pictures, some people prefer words. It's the exact same thing, except it's got a new term here called genotype. And remember I said that you have 2 copies of every chromosome, assuming that you're healthy, that you don't have like Down syndrome or Turner syndrome or something like that. You've got 2 copies of every chromosome. And so there are 2 ways to have type A blood. One way is to have 2 chromosomes both chromosomes have the A gene. The other way is to have one chromosome that has the A gene and one chromosome that has the O gene. So even though you have half your blood cells have no antigens on it, the other half was going to have the antigen for A. And so that's called the genotype. It's literally which genes do you have. Type B, you can either be two Bs or a B and an O. AB, you must have an A and a B. So there's no other way. And O means you have both of them are O's. Okay, so, and we'll explain genes and how to do the Punnett square and figure out that kind of stuff later on.
Is that like the Gregor Mendel?
It's Gregor Mendel, yes. Mm-hmm. Awesome, you already remember that from high school?
Yeah,
He worked with peas and flowers and stuff like that. And once again, this is just another way, except this time they actually show the little these are chromosome pictures, like what the chromosomes kind of look like. They have a long end and kind of a short end, and so that's why it's not the letter I. But that's just to physically show, okay, that's one chromosome has the A gene, one does not. And so therefore, you've got blood type A, and you can receive blood from either other type A people or O people. And then we have B, and we have the AB. AB, especially if you're AB positive, it's rare. However, you can get blood from anyone. I mean, assuming that both people are healthy, you don't want to get blood from someone who has some type of bloodborne disease, but, whereas if you're O, especially O negative, you can only receive blood from other O negative people. If you're O positive, you can receive blood from O negative or O positive people. So that's why the universal donor is called O negative. The universal acceptor is AB positive. This is just a little, I don't remember what year I got this from, but this just shows the percentage of the blood types based off of ethnicity. And of course it becomes, in our society, it becomes more and more difficult since we are a blended society. But you can see over 1/3 of the Caucasians / European Americans, over 1/3 is O positive. Whereas O negative is fairly rare across the board. And then AB negative, as you can see here, is really, really rare if you're AB negative. And so, especially if you were of Asian descent, that's 1/10 of 1%. So that'd be out of 1,000 people, that'd be one person out of every 1,000 Asians would have type AB negative blood. Okay. Alright, I just put that out there because it's interesting. If you're Hispanic, there's a good chance, in the United States, there's a good chance that you're going to be O positive. I mean, more than 50% chance. Alright. I have not tested this link. In fact, it won't work on this to make sure, see if it works still. But we have to have ways to test for the blood, to know what blood type that you have. And the one that we're going to do in lab in a couple of weeks is actually a form of what's called the precipitin test. Okay? But I just wanted to explain some of these, and I want you to know how these work, to know what they are. So, I'm going to actually start with the precipitin test to begin with. What does precipitin sound like? Precipitation, what is precipitation?
Water.
Not just water, but it could be rain, it could also be, in weather-wise, rain, snow, sleet, ice, but it's falling down, okay? And that's actually what happens here. If you think back to that picture of the way that the antibodies clump up and they agglutinate, when they do that, they become solid and they precipitate, they fall out of solution. And so we utilize antibodies. So I buy the antibodies, the anti-A, the anti-B, and the anti-D, which is the rhesus factor. You can just buy those. And so you put a little bit of blood. In fact, that's how you're going to test your own blood type. You prick yourself, you bleed, and then you just divide it up in different wells. and you add an antibody into each little well and see which one precipitates. If it precipitates, then that's a positive. So for example, if you add in anti-A and it precipitates, that means you had type A blood because it recognized it and it wanted, it thinks that it's bad, and so it's going to precipitate out so it can get chewed up if it was inside your body. If it was B, it would be the anti-B that would cause it to precipitate out. If it's O, it doesn't precipitate out using either. Okay, so that's why it's called the precipitin test, is you use the antibodies in order to test to see what blood type it is. It's really fast. Pardon?
Is that how they test it? Like, how do they normally test it that way?
Yeah, nowadays it's really, really fast. You're going to be able to do it in a minute or so in the lab, assuming that you can get blood out of your finger. Okay, now if you have very small amounts of blood, it may be hard to see, so you may have to use a microscope to see if you can find the solid or not. Okay, don't worry, we actually use lancets. We don't do it the way that I had to do it, where you just stabbed yourself. We have lancets similar to like the diabetic kind. So it just looks like a little square box. Surely not like a wimp. But we'll clean. You'll use an alcohol swab or something, or a cotton ball with alcohol to clean off your finger. And beforehand, you may even want to work it a little bit to get it nice and warm, and also get the blood down in there. But you clean it off, and then it just looks like a little box. You put it right there, and then you just hit it, and the needle comes out and pops real quick, and then it's back. So then the blood comes out. And what we do is that we actually have, one way to do it is it's a card that's got the antibodies already there, or it's a card where you put a little bit of blood on each spot, and then you add in the antibodies and mix it and see which one precipitates. And so it's really fast nowadays. So you pretty much use some type of version of the precipitin test. Now, luminol. What is luminol? That's one that you see a lot in the news or on TV shows. What does luminol?
Don't they look for the use a UV light?
Right. It fluoresces, or luminescence is technically the term for it. And so they have to use like the black light or the UV light. But in the presence of blood, it glows. Okay? And so it doesn't tell you anything about blood type, like the precipitin test does, but it'll let you know that there's a presence of blood. Now, there are some things that give off false positives. Sometimes cleaning reagents, so you may even be able to tell if someone's been cleaning at a crime scene, because it'll glow. Okay? But luminol is usually used to help find blood, because it's pretty precise, and so that's why you may not think that there's any blood there. You spray luminol, you turn off all the lights, make it dark, you put that UV, the black light. If it glows, then that's a good sign that there's blood there. The microcrystalline test is where it is similar to precipitin, except instead of adding antibodies, you add specific chemicals that react with blood, and instead of it falling out, it forms little crystals. It's more time consuming than the precipitin test. Okay. Precipitin test is very specific since you're using antibodies. This is using a chemical to make little crystals forming, and then you can look at it under a microscope or something like that. And then the color test. This used to be used a lot. It's literally where you add a chemical and it reacts with the hemoglobin in blood. That's what has iron in it and carries your oxygen for you. And it would turn a color. And so it was something that you could do pretty quickly out in the field. If you thought something was blood and you wanted to make sure, you just swabbed it, you sprayed it, and it would turn colors. You see that sometimes still with like phenolphthalein. It does give false positives. So just because it turns pink means most likely it's blood, but you can't say for sure until you take it back and you do a precipitin test, or you find out if there's DNA present, things like that. Okay, and the reason why is it gives false positives. There are other things that contain iron and stuff in it naturally occurring that could react and give a positive. But if it does come back positive, you want to make sure that you follow up with a secondary test. So this is just a couple of pictures. So you can see here's just some chemically synthesized luminol to show how bright it can glow. And I actually have the Actually, I think I've ordered some luminol. We've never used it yet because it is kind of expensive. And I even found a way to make it ourselves for organic chemistry students. I just haven't ever had the time to, or anyone in organic chemistry that really wanted to do it. But it does glow in the presence of blood. And this is a bloody footprint that they were able to see. And then, of course, I like this picture because it's the same place, but you can see it with the lights on versus the lights off. So even though they tried to hide and clean up the blood, you were able to see it. This is the gel precipitin test. Okay, so it's the exact same thing that I was talking about with using antibodies, except you put it inside a gel. And the reason being is in order for the antibody and the antigen to bind so tightly, they have to have opposite charges. You know, opposites attract. And so you literally put the potential blood sample on one side of the gel, the antibodies on the other side, and you turn on the battery. And since they're the opposite charges, they go towards each other. What happens is, as they go towards each other, they're going to pass. If, let's say that this was, if this was type, this is the antibody. Say that this was anti-B, and the blood sample really was type B. Whenever they come together, they would actually form a solid, and you get a line. It literally, you can see it then. It will form. If instead it was anti-B and you had type A or type O in there, they would just literally pass each other. They won't react because it's the wrong antibody, and so then you don't see a line at all. And so you just run this gel with all the different types, and you see where the little line forms. Okay, we tried to do this once in the lab, and it was just the fact that our blood samples were too dilute. I don't want you guys to have to bleed too much. Or I buy blood, but blood is really expensive. Human blood is more expensive than what you'd think. So, let's see, network Wi-Fi. Once again, essentially it's identical to the precipitin itself, except you're doing it inside a gel versus just doing it on a piece of paper, or the way that we do blood that you're going to have just regular blood samples. We use what's called a chem plate. It's just a little plate that's got little divots in it, like little, almost like little bowls, little well cut out, and you just put a drop of blood in each one, and then you put a drop of the antibody, you mix it, and you just let it set for a little bit and see if it forms a solid or not. And if it does, then that's a positive result. And so, yep.
How would this be more positive than the original precipitin test, or like why is this used instead, I guess?
They would use this one in the event that it doesn't require as much material.
Oh, okay.
Because you can have really tiny wells, whereas otherwise it's pretty much the same. The one that we do in class, it uses a larger volume because you have to put a drop or two of blood in and a drop or two of the antibodies, but you may not have that much material, if in a forensics lab. And so, yep. Okay, don't